Hi everyone, welcome to the channel. Today I'll be talking about Euclid's elements. I've prepared another mind map for you here, so let's jump in. The prerequisite for this video is the previous video I made, my first ever video, which is about well-defined concepts and noumena. So I urge you to watch that before watching this presentation. This presentation will be quite lengthy, so I will be breaking it down into a playlist. Today in this video I'll just be doing the introduction. So I'd like to make a note and please compare this lengthy analysis to the mainstream, very brief and arbitrary definition of axioms. So in the mainstream, Euclid is rarely taught or discussed anyway, but in the few times Euclid's elements are discussed, it's basically just, these are the axioms and let's move on with our lives. And usually there's a criticism about the fifth quote axiom, which is actually very problematic, and I'll get into that later. So, first of all, Euclid does not use the word axiom. But we can deduce, as we will show, his framework or thinking. The word axiom is actually just a projection of the zeitgeist of the 19th and 20th century of mathematics. I will be critical of Professor Weilberger, but his critique on this zeitgeist is actually quite solid. And more on this later. So in order to deduce Euclid's framework and thinking, we actually require deep thought and study. So mainstream presentations on Euclid and Euclid's elements illustrate that the texts are not studied, nor deeply, that are not properly studied and not deeply analyzed. So examples of this is Norman Weilberger, very popular channels with millions of subscribers like Numberphile, and all other videos. So I'll show just a simple YouTube search with playlists about Euclid, and all of them are wanting. So with Professor Weilberger, I'll be making a whole playlist on my critique on him, but at least he does an attempt, but I should say a failed attempt. So I'll just briefly show you some examples of what I'm talking about. So initially, as I said, if you just search Euclid, if you search YouTube for Euclid's elements, nearly all playlists on the topic, except, well, a specific one, but I'll leave that as a riddle for you. If you can find one specific playlist other than this that has some real value and talks about the subject much more in depth. But most other playlists, most mainstream playlists, don't really have any sort of introduction about Euclid. They give no context. They simply state the quote axioms and move on to proofs. And there isn't a single playlist on YouTube which is complete and thorough. An example of what I was talking about previously is this video from Numberphile. Numberphile is a YouTube channel about mathematics which has 4 million subscribers. This video has 400,000 views, 7,500 likes, and 550 comments, and I've gone through a lot of them and they're overwhelmingly positive. If one sees this video, it's so lacking. This professor has no idea of Euclid. He even makes mistakes on stating the quote axioms themselves, and he does a terrible job at explaining it. And this is what has popular demand and overwhelming positive support. And this is Professor Weilberger. He has some criticisms of Euclid and his work, which, as I said, I'll make a whole playlist on that, showing logical fallacies, contradictions, and much more. So back to the mind map. So all modern mathematics issues stem from misunderstanding Euclid or omitting Euclid. This is akin to the supposed irrational crisis of the Pythagoreans, that there was a crisis when supposedly the Pythagoreans discovered a square root of 2. And this is simply a fictional crisis based on misunderstanding. So this is again a projection, as I was saying earlier, that modern mathematicians think, with no evidence, actually the mathematical evidence shows exactly the contrary, that there was a supposed crisis with square root 2, and they're doing exactly the same thing. The whole of the history of mathematics is formed around a crisis or lacking, or the Euclid is found lacking when it's actually simply misunderstood, and Euclid's elements are more or less perfect. So misunderstanding of misunderstanding of Euclid. So an example of the misunderstanding of Euclid is the axiomatic program for mathematics that was developed in the time that I said previously, 19th, 20th century, and even previously with supposed non-Euclidean geometry. Non-Euclidean geometry as a term makes no sense. First of all, from the previous video, we showed that we cannot define anything in terms of attributes that it lacks, so that's indicative. But also we can just see that spherical geometry existed in ancient Greece and it was exceptionally advanced. If you look, I urge you just to look at Ptolemy's Almagest. That is extremely advanced spherical trigonometry and spherical geometry. So yes, back to the axiomatic program. Figures like Russell and Hilbert were promoters of this idea that Euclid and mathematics and geometry as a whole had to be reformed around their sort of ill-thought philosophies, and this led to a decline in the teaching of geometry, and especially nowadays geometry is totally omitted and not well taught altogether. So yes, omitting of Euclid, the Bourbaki group, I think they were in the 1950s. Imagine I think the whole banner was down with Euclid. This was a fanatical approach to leave the real foundations of mathematics and go into this sort of real analysis, this analytical way of thinking in modern times, which is totally broken. So all modern mathematics issues, as I said, stem from misunderstanding Euclid or omitting Euclid altogether. And the issues also stem from irrational concepts and thought processes. But this is basically the same point. This is same as the previous 2 points, which is misunderstanding Euclid and omitting Euclid. So if you misunderstand or omit Euclid, your thinking process is irrational and broken, because Euclid is perfect if well understood. Examples of this are, quote, irrational or complex numbers, infinity, set theory, etc. So as I said, yes, Euclid is rarely even discussed, and just to see the evidence of this, see an undergraduate mathematics program, a modern undergraduate mathematics program. So even a novice can tell the difference from this analysis I will be doing now and the typical analysis of quickly brushing over the supposed axioms, not giving any context to Euclid, not looking at the history of mathematics before Euclid. So it might be, though, actually better that the viewer is a novice, because they might have more of an open mind. So, use of tools for construction. Many times there's criticism about Euclid using pictures, or the fact that ancient Greek geometry is simply has this limitation of using a straight edge and a compass. So, to understand a straight edge and a compass, this is actually much more deep. It's not just a straight edge and a compass aren't actually just tools. It's not only about tools and visuals and visual understandings per se, but actually it's about ideas or manifestations or abstractions. A rule and a compass is actually like rules or processes. They're primitives with which we use these primitives to build complexity. These are instantiations, these are instances of well-defined concepts. Because what is a straight edge? It's a straight edge. We can think about it abstractly as the connection of 2 points with a shortest path that connects 2 points. So this, as we said in the previous video, this is a well-defined concept, and it's the definition of a straight line. So yes, as I said, a compass is the relation of 2 points, and a straight edge is the connection of those points with the shortest path, which is the straight line. So a compass is actually more, with a compass we define points, and we can define a circle, which is a well-defined concept. In actuality, what a compass is actually just 2 points. A compass can actually also be used for measurement, because we can use it to compare magnitudes and lengths, and we can define a measure with it. So we can define the monad 1 as being any measure that we choose it to be, and then everything is relation to that 1. So one of the most important things of understanding Euclid is to put Euclid in context. So Euclid was a librarian, mathematician in the greatest library of ancient times. To understand Euclid, one must study ancient Greek mathematics prior to Euclid. So what did Euclid actually do? Well, it's apparent there were great works previous to his, and from his methodology it's apparent that what he did actually was to derive the essence from all past works and build a systematic framework of thought and of mathematics. So we can think of the requirements, the 5 requirements and his whole framework, as an extraction process akin to, for instance, as the scientific method was used with British empiricism. So via the scientific method and experimentation, the laws are deduced, the irreducible law is deduced, and then in turn it's used to build everything else. At the same time, we can think of it conversely, of Euclid building a systematic framework from absolute zero, and I'll be talking about this in the next video when I give a preface to the requirements. Something that came to mind is this homeomorphic sort of attribute, where if we look at it bottom up, building everything from zero, or if we look at it in terms of extraction of the requirements, it's actually the same thing. And this also illustrates well-defined concepts in noumena that exists within these mathematics. So they're discovered from zero as we're trying to build from zero, or from various examples of intuitive mathematics that existed prior to Euclid. In those mathematics, the elements are always contained, so they will always be they can always be deduced because they're contained within those mathematics. And this just simply yet again shows the idea of noumena and mathematics being noumena. So yes, Euclid is more than geometry. It's actually about systematic and clear and well-defined thought. It is the first and only true pure mathematics. And something that helped me in thinking of mathematics, even from the etymology of the word mathematics, it has contained is the Greek word mathesis, manthano, which is to learn. So I think of mathematics also as meta-learning or meta-programming. Primitive mathematics is discovered since forever. Even animals have understanding. But once the notion of proof is established and mathematics is used as a framework, there's a quantum leap. And this is what happened with Euclid in this sort of meta-programming, meta-learning framework. There can only be one true foundation for mathematics, and it's discovered, not created, as I said in the previous video. So Euclid's Elements is a pure derivation of mathematics from nothing. It's irreducible, and the name is indicative because it's called stihia. Stihia in Greek is the elements, but what are elements? They're irreducible first principles. And Euclid's elements are not arbitrary. They start from zero and they all have perfect relation in succession. They have a successive relation that one relates to the next one perfectly. So we have primitives, which are well-defined concepts. Well, this actually is sort of, I drew inspiration from this book. It's one of the most, this book, Structure and Interpretation of Computer Programs, is actually considered probably the greatest book on programming that's ever been written. And in it, it has a quote from John Locke about all systematic thought, all knowledge being simply primitives, and then the next stage is having means of combinations of these primitives and means of abstraction. And the whole framework with structure and interpretation of computer programs uses is sort of this idea. And I believe this also has a lot to do with Euclid and his approach. It also is akin to binary logic in computers, with which we further build complexity, and the process repeats, and we can just build more and more complexity if we have proper primitives and proper means of combination and then abstraction. And it's also indicative because the same issue with programming, I believe there's a crisis in programming, and a lot of experts believe the same. And the same problem in programming exists as in mathematics, where both subjects have gone off the rails, and this pure triangle of primitives, means of combination and means of abstraction should be the core of these subjects, and these subjects can be thought in that way. And this idea is simply forgotten. So I think this is it for this video, and in the next one we'll have a preface for the requirements of Euclid. So thanks for joining me, and see you in the next one. Thanks, bye.